All right, guys, so we have a meter stick. Now look, first sentence, the meter that tells us the meter stick is found to balance at the 49.7 centimeter mark. What's that telling us? If the meter stick balances, if you support the meter stick right there, boom, and that point right there happens to be at the 49.7 centimeter mark, what's that telling us? This point right here must be the what? That's the center of mass. That's the center of mass for the meter stick. Close to the middle, you know, close to the middle. If they didn't tell you that, if they didn't specify this, where would you assume the center of mass to be? At the 50, right? If they don't tell you this, then you just go, okay, the center of mass is going to be directly in the middle. Okay, so the center of mass is going to be boom right there. So look, I'm going to draw mg down for, this is the weight of the meter stick. So this is going to be mass of the, well, let's call it a ruler. Mass of ruler times gravity, mg, right? Okay, and then this point right here, let's mark it. This point is 49.7 centimeters. Okay, when a 50-gram mass is attached at the 10 centimeter mark, so the 10 centimeter mark will be somewhere in here. This is 10 centimeters. So we're hanging a mass over here. Boom. So 50 grams is 0.05 kilograms, right? Convert this to kilograms, 0.05 kilograms. So multiply that by 9.8. and you get 0.49 newtons. So the weight that's hanging over here, it's basically a 0.49 newton force on the meter stick. That make sense? Then they tell us, so when that 50-gram mass is attached there, the fulcrum must be moved to the 39.2 centimeter mark for balance. Okay, so we're gonna be sticking the fulcrum like somewhere in here. So the meter stick is balancing, right? We're balancing the meter stick. So this point right there is the axis, right? That's the axis. So let's mark this point. That point right there, 39.2 centimeters, okay? Hey, there's one more force here. What's the one additional force? The meter stick, is it resting on a surface? Yeah, so there's going to be a normal force right here. There's a normal force right there where it rests. But look, is that normal force causing a torque? Because why? Well, here's the torque equation. Torque equals force times lever arm. What's the definition of lever arm? Lever arm is defined as what? Distance from axis to force, perpendicular, okay? Notice that the normal force is directly on the axis. So what's R for the normal force? 0. So the normal force is causing no torque, okay? Now, so how many torques do we have? Hey, what's the definition of torque? It's the ability of a force to rotate an object. That's what torque is. It's the ability of a force to rotate an object. Does this force over here have an ability to rotate the meter stick? It does. Does this force over here have an ability to rotate the meter stick? It does. So we have two torques. There's two torques, and these guys are them. Those are the two torques. Now, the sign convention for torque, it's not going to be up plus and down minus. That's not the sign convention. What's torque all about? It's all about rotation, right? So the sign convention is going to be clockwise, counterclockwise. It doesn't matter which one's plus and which one's minus. So this force over here, which way is this trying to rotate the meter stick? Clockwise or counterclockwise? Counterclockwise. So CCW for counterclockwise. This guy's trying to rotate the meter stick clockwise, right? So let's just say that clockwise is plus, counterclockwise is minus. If you want to say the opposite, that's fine. As long as you're consistent, it's fine. Okay, so we got to figure out distances. Where are the distances always measured from? From the axis. Okay, so what's the distance from the axis, which is here, over to this force? What's the distance there? 29.2 centimeters, right? What's the distance from the axis over to the other force? Well, you got to subtract those two numbers, and you get 10.5 centimeters. Now look, are those distances perpendicular to the force? Are they perpendicular? Yes. Yes, they're perpendicular, so we're good. Okay, so now we're ready. Let's sum the torques, starting with the positive guy. So what's the force? So here's our torque equation, right? Torque is force times lever arm. What's the force for this guy? Mass of ruler times gravity. Okay, and then what's the distance? 10.5 centimeters. You know what? You could leave. Normally you want to be in meters. It's not going to matter here because the centimeters will cancel. Okay, so this is the torque for this force. Okay, now this guy's minus. The force is 0.49, and then what's the distance? 29.2 centimeters. Okay, these two torques, if the meter stick balances, what must the two torques be doing? Canceling. So now the only thing you don't know in here is the mass of the ruler. You solve it for mass of ruler, and you get 0.139 kilograms, which is 139 grams.